Welcome to this week's Midweek Space Startup News. So I'm going to go over some news articles I found on websites and on social media posts. But first of all, please follow us on X if you have an X account. We're at Space Startup Hub. When I post a long form video, I typically summarize it in a number of X posts with a link to the video. With that, let's get into the first article of the week. And this is spacenews.com. And I will link all these articles down in the video description. The article is NASA to increase value of CLPS, that's Commercial Lunar Payload Services contract, to support surge of lunar lander missions. So I'll read the highlighted sections of this article. NASA is planning to increase the total value of a contract for robotic lunar lander missions to support a proposed surge in flights for the agency's moon base plans. So this is NASA's pivot on the moon base to a phased approach. So it'll be phase 1, phase 2, and phase 3. And there's going to be a big increase in the number of lunar landers to support the moon base. So the article goes on to say, increase the maximum value of CLPS contracts from $2.6 billion to $4.2 billion. So that's a very substantial increase in value there. And planning is underway for a follow-on contract called CLPS 2.0. So CLPS 2.0 will be a new contract, and hopefully it will be extremely well funded. So hopefully we'll see lunar startups managing to get their payloads onto some of these new lunar landers. So NASA has awarded task orders for less than $2 billion to date, and they're planning to award more missions or more valuable missions over the next 2 years. Either they can increase the amount they award to each lunar lander, or they can just schedule more lunar landers. So we'll see what happens there. So we have Joel Kearns, who's a Deputy Associate Administrator at NASA, and he says, we're looking into opportunities to buy into that ramp of demand for the very short term, even as we are working on issuing the CLPS 2.0 contract competition, unquote. At NASA's Ignition event, and I covered it in a previous video about this Ignition event and NASA's pivot to the surface of the moon and their phased approach to building up a moon base. And it requires a sharp increase in the number of robotic lunar landings. That included 9 landings in 2027 and 10 in 2028. That's almost a landing every month. And down here it says Firefly now has 3 landers in production, Blue Ghost 2, 3, and 4. And Blue Origin is finishing testing of its first Blue Moon Mark 1 lander. This is the cargo lander. Mark 2 is the crewed lander. And they're also manufacturing components for the second Mark 1 lander, which the company plans to use for NASA's Viper rover in 2027. Viper is the very expensive NASA rover that's looking for lunar water ice. It has a drill. It can drill into the regolith and look for traces of water ice. So the Viper rover was cancelled even though it was completed because it ran over budget. But now it's been allocated to Blue Origin's second Mark 1 lander, which is good news. And we have a quote here from Blue Origin. We're excited about the challenge and we want to show off our stuff, unquote. And then Ben Boosie, who's chief scientist at Intuitive Machines, the key, if you're trying to ramp that up to multiple missions per year, is knowing you've got a supply chain that can do it in time, or bring things in-house, he said. And then he added about early CLPS missions. Each lander was slightly bespoke, modified to meet the needs of its payloads. That's less likely to be the case as flight rates increase. I think you'll see some kind of standardization. Going to build to print landers is maybe the response to the signal. We're going to build to print dozens of landers to help NASA achieve its goals, unquote. So that is the article, and that's from spacenews.com. Let's talk about it. So this is NASA's new phased approach to building a moon base on the surface of the moon. Lunar Gateway has been scrapped, cancelled, paused, whatever you want to call it. So now there's a 3-phase approach. Phase 1, which we're in now, which be mostly tech demonstrations, lunar landers, reconnaissance, surveying, that kind of thing. And then phase 2, you will start to see the habitation module, power units, and so on. And then phase 3 will include things like in situ resource utilization, perhaps a nuclear power plant, and so on, and building out the habitat. NASA is now focusing very heavily on the surface of the moon, and all the NASA centers are working to that one goal. I think it's a really good approach. And we have this slide from the Ignition event. So you can see the transportation landers. In the middle, you've got the Lunar Starship. You've got Blue Ghost at the top. You've got iSpace, Apex Lander. You've got the Blue Origin Mark II. You've got Blue Origin Mark I. and you've got Intuitive Machines. So we have a look at Firefly Aerospace. Of the 4 CLPS missions, the only one that was 100% successful is the Blue Ghost Mission 1 from Firefly Aerospace. Here are the missions. So Mission 1 was successful. That was the beginning of 2025. Delivered 10 NASA payloads to Mare Crisium on the moon's near side. Blue Ghost Mission 2 is scheduled for the end of this year, probably December 2026. And then we have Mission 3 and Mission 4, 28 and 29. So as you can see, they have plenty of lunar landers scheduled. Their first mission was very successful, absolutely perfect. The other 3 missions were not as successful. This is Intuitive Machines Mission 2, which toppled over. Mission 1 also toppled over, but many of the NASA payloads were able to still function and send data back to NASA. So even though it wasn't technically a success, I think NASA's quite pleased with Mission 1. Mission 2 was a complete failure. Then we have, so you can see the Astrobotic lander, and this looks like the Flip rover from Astrolab. Their first mission was a Peregrine lander that failed in Earth orbit, so it didn't get very far. Their second lunar lander, I believe, is called Griffin, and that should be launching, I don't know, later this year or next year. So hopefully they can get to the moon's orbit and then stick the landing. This is Blue Ghost Mission 2, and you can see in the inset, you've got this light port here. This is from Volta Space, which I've covered on this channel already. And their plan is to beam power from orbit to lunar landers or lunar rovers. And you can see a little device there just to test whether that works. In this case, they're just going to use the sun to convert solar energy into electrical power. So that's on Blue Ghost Mission 2. These are the companies working on CLPS 1.0. So you can see Blue Origin, Lockheed Martin, Astrobotic, and some others. So hopefully CLPS 2.0 will onboard a lot more companies. And here we can see where they landed or where they plan to land. So Blue Ghost Mission 2 will be landing on the far side of the moon. And Team Draper is actually using iSpace Lunar Lander. So they've tried several times to land on the moon and failed. Now the iSpace US office is working on a larger lander, as you can see here. I think it's called the Apex lander. And this is part of Team Draper. So let's look at this video. This is the Blue Ghost Mission 1 orbiting the moon. And that was a very successful mission. We do have a render of Intuitive Machine lander with a micro hopper, and it has a drill as well. I believe Intuitive Machines has 4 missions in total. That's a little micro hopper that can actually go into a crater, take images and video, and then take off again. So that is Intuitive Machines. This is very good news that NASA is putting more money into the lunar landers, which in turn means lunar startups can put their payloads onto these landers, start doing tech demonstration, and then iterating towards a commercial service. So this is very good news. Okay, let's move on to the next story. Okay, our second story is from Payload Space, so let's have a look at it. So this story is titled Space Nuclear Execs Cheer the Financial Year 27 Budget Proposal. So the article says the proposal is to require space nuclear power for lunar spacecraft to survive the lunar night and to support human efforts on Mars. So the NASA budget will allocate $438.8 million for Mars technology, which includes the development of fission reactors as a major focus, $135.3 million for radioisotope power systems through a partnership with the Department of Energy, and $100 million for the Harmonia radioisotope power system, which I'll talk about in a moment, and $55.4 million in additional funds for the development of commercial radioisotope systems for use on the moon. And a quote from Jared Isaacman, the NASA administrator: "You will not find an administrator that is a greater champion of nuclear power and propulsion than me," unquote. So that is the article. Let's talk about nuclear power on the surface of the moon. So we have this graphic from the NASA Ignition event, and you can see here, this is phase 1, by the way. It says now through 2028. So you can see here, it says radioisotope heating units, or RHUs. So RHUs are hot rocks in a box. You basically put rocks that are radioactive into a box and you get thermal heat. That's it. And that's enough to heat a lander or a rover over the lunar night, which lasts 2 weeks. There's various companies working on these RHUs. Execs in Australia provides RHUs. Xenopower in the US also does. And there's some companies in Europe as well. So I've covered a number of these startups on my channel already. If we have a look at another slide from the NASA Ignition event, you can see in the bottom left corner, RHU survived the night. These radioactive heating units are specifically for keeping a lunar lander alive over the 2-week lunar night. And they can also be used for rovers for the same reason. And we have an image here. You can see the Intuitive Machines lunar lander. And here you have a nuclear battery from Zeno Power. That just slots in and it provides enough thermal heat to keep all the systems alive. So the batteries won't freeze, for example. And when the sun comes back up, it can revive and continue its mission. So NASA ranked 187 capability gaps they have. And the number one issue, according to NASA, is survive and operate through the lunar night. So this is a major issue for NASA. They have to solve. RHUs and RTGs, radioisotopic thermal electric generators, are one very good way of doing that. So the article mentioned the Harmonia project, and if we bring that up, this is from NASA's TechPort website, Harmonia radioisotope power supply for Artemis. And this is a proposal. And if you look at the bottom here, you can see the organizations. Zeno Power is leading that project. You also got contributions from Blue Origin, Intuitive Machines, and some others. So the idea with the Harmonia project is to provide an advanced RTG system using americium-241 that has a very long half-life, 432 years. So any system powered by this RTG will last for many, many decades and even centuries. NASA is working towards nuclear reactors on the moon as well. So it's RHUs for heating, RTGs for thermal heat and electricity, and nuclear reactors to power a base on the moon and then later Mars. And also to use nuclear reactors on spacecraft to be able to move efficiently around the solar system. Okay, our final story this week is from GeekWire, and it's titled Interlune wins $6.9 million NASA contract to create system to extract helium-3 and hydrogen from moon dirt. So the contract is for Interlune to develop a system that can extract gases such as helium-3 and hydrogen from lunar soil and rocks. And it will be launched to the moon on a commercial robotic lander in 2028. And helium-3 can be used for various things, including commercial nuclear fusion. As we talked about in the video just released on pulsar fusion, which requires helium-3 for its fusion drive. Interlune's payload will include particle sorting device, hardware for heating up lunar material and harvesting the gases that are given off, and also a mass spectrometer that can analyze the gases. And we have a quote here from Interlune's chief scientist, Elizabeth Frank. And she says, "For the first time ever, we will measure volatile gases by heating lunar regolith or lunar soil while on the moon. The data we collect will also tell us how much power is needed to extract resources like helium-3. And the company plans to send a camera to the moon on Astrolab's FLIP rover, and that mission is called Crescent Moon. Interlune says it already has nearly 500 million, that's $500 million, in binding purchase orders for helium-3 from quantum computing companies and obviously from fusion startups and for neutron detectors, and the US government, including the US Department of Energy and the Department of the Air Force. So helium-3 is the first resource targeted by Interlune, but the company plans to widen its focus to extract valuable materials from lunar regolith, including industrial metals, rare earth materials, and water. So that is the article. So let's talk about Interlune and helium-3 mining on the moon. As I explained on the video on Pulsar Fusion, which is a company working on fusion drives, those fusion drives have to be powered by clean nuclear fuels. And that means in practice, deuterium and helium-3. And helium-3 is extremely rare on Earth. This is why companies are starting to look at the moon, which has 1 million tons of helium-3 right on the surface, literally on the surface. And I'll go a bit more into detail on that in a moment, but first let's have a look at the core model for lunar helium-3 mining. So you excavate the lunar soil on the lunar regolith, you heat the soil, you capture the volatiles, and then you return the volatiles to Earth for separation. You can't separate helium-3 on the moon without putting a lot of mass and a lot of technology to do that. It's quite complicated. So in practice, you'll just take all the light volatiles. The light volatiles will be hydrogen, helium-3, and helium-4. Those you send back to Earth, And then on Earth, you will separate out the helium-3 and you can sell it for $20 million per kilo. Helium-3 is the ideal fusion fuel. Every fusion startup company would like to use helium-3. So that is the business plan. These are the missions that Interlune are planning. So the article talked about Crescent Moon, which is the mission coming up this year, and that will be on the Astrobotic mission using the Flip rover. And you can see it here. There's the Astrobotic lander, and here's the Flip rover, and the payload will be on this rover here. So go back to this slide. This is the upcoming mission, Crescent Moon. Then in 2027, there'll be Prospect Moon. This will be a lander with sensors and extraction demos. And then in 2028, the Harvest Moon. This is end-to-end extraction and return to Earth. And they have a Department of Energy contract to deliver, I think it's 3 liters. So that will be the first commercial sale of helium-3 in 2028. And apparently they have $500 million of binding contracts for helium-3, which doesn't surprise me at all. They can sell all the helium-3 they can extract. This is why I'm concerned about pulsar fusion. There will be a lot of customers who will be happy to pay $20 million per kilo for helium-3, including the fusion startups and the quantum computing industry. So pulsar fusion could be at the end of the queue. So anyway, that is all the stories this week. So thank you for watching, and please leave your comments down below and I'll read some of them out at the weekend live stream. So thank you for watching, and I will see you next time.